What is the best way to train a foundation model for sequential decision making? Okay, I have no clue what sequential decision making is. I would assume you make decisions after each other. Some of these are very special. Hello, my name is Lukas. I'm a PhD student at ETH Zürich, and today I will answer impossible questions by researchers. I'm here with a research paper with a benchmark on explainable AI evaluation, actually showing if explainable AI agree or disagree with each other and what this means for evaluation of explainable AI. So the question is, how do you handle and debug failures in long-running experiments? I think the most important part is to recognize the failures so that you have a good view over your log files, that you know what is going on. And if you recognize the failures, that you have like breakpoints in between, that you can say, okay, I can start over from like some checkpoint 2 days ago or whatever, so that you don't have to start from scratch. How can we build autoencoders that conserve high spatial frequencies in the data? I would maybe say, okay, you need a very expressive latent space which still captures spatial information and not only semantic information. So you try not only to compress your semantic features from the input space, but still have some idea about the spatial dependencies, which you have, for example, I don't know, in VQ, VIE, etc. What is the best way to train a foundation model for sequential decision making? How can we gather and use massive amounts of data to train it? For sequential decision making. Okay, I have no clue what sequential decision making is. I would assume you make decisions after each other. So there is some longitudinal dependency in that. I assume any data you can scrape which has the sequential dependency in it, for example, like chat data where you have interactions which depend on each other. But that's a educated guess at best. What combination of existing tech plus new developments will it take for us to run billion parameter architectures on edge devices? There will be a lot of model quantization going on here, I think, to deploy it on such small devices. I think the domain of specialized processors will also have a lot of impact here, to at least allow the computing make the computing as efficient as possible on these small devices with the least amount of excessive heat you can produce possible. Some of these are very special. What do you think will be superseded first, the transformer architecture or PyTorch? Well, that's a good question. I would say the transformer architecture. There's much more research going on right now to find the next transformer architecture than to develop the next framework for model implementation. I think it's much more complicated to transfer to such good ecosystem and community like PyTorch compared to something like a transformer architecture, which you can swap out quite easily. So I would go for the transformer architecture at least.